Hello everyone, and welcome to yet another problem from Geeks for Geeks. The problem is very simple and it asks us, do you know heap? Because the problem is check if the array is max heap. Now, the problem is very simple. It says given an array ARR, determine whether it represents the level order traversal of a valid max heap. Return true if it does, otherwise return false. So this is an array, and this is a representation of an array as a tree, and you can see it is max heap. Well, how can I say that it is a max heap? Because you see, every child is lesser or has a parent which is maximum than it. So 10 has a parent which is maximum than it, 2 has a parent which is maximum, 12 has a parent maximum, 7 has a parent maximum. So can I say that it, and this is a definition. So heap means current should always be lesser than parent, and this is for max heap. Min heap is different from this. Min heap is current should is greater than parent. So parent whatever maximum, then it's max heap. Parent whatever minimum, then min heap. So considering parent as a root, so 90 is the maximum, topmost maximum element you can get. Similarly, this is not a max heap. Why it is not max heap? So 9, which is parent of 15 and 10, it's not greater than 15 and 10 both. So it's not a max heap. Again, 11 and 10, this is again not a max heap because 10 is lesser than 11. But this is not the end of problem. The problem is still pending, that how can you find out the current and the parent, and not to mention the left and rights. So we have known that, hey, I have just want to understand that, hey, current is always lesser than parent, and I need to do it for every other nodes, that means left, right, and the current node itself. So if I can check individually, so check individual, I hope the spelling is correct, but anyways, starting from 0, and if boolean int a and int current node, or current I will say just, and I wanted to just check from left and right, so return check initial a of left and a of right, and obviously a few checks here as well for validation and current check, validation check and current check. But how are we going to find out left and right? So this is a standard problem. This is a standard case where you are representing a tree as an array, and for that you have two things. For left, from a current, considering that, hey, I am on a root, and if I wanted to go on the left is nothing but root multiplied by 2 plus 1, and right is nothing but root multiplied by 2 plus 2. Now let us verify it. We have 90, index 0, 0 multiplied by 2 plus 1 is 1, which is 15. So 19 is a parent of 15, correct. Now upon right of 19, how I can get to know? 0 multiplied by 2, which is 0, plus 2, index 2, 1, 2. So right is 10. That is how I got it. And there is also one thing, if you know either of the current node, I wanted to get a parent out of it, you just do current minus 1 divided by 2, and yeah, this is it. So if you wanted to get a parent, which we need to get, because parent is this, and we need to get parent. Why? Because we have to check that, hey, my current score should not exceed. If it exceeds, then my parent then it's not a valid tree. I would return false. And in any case, if I'm seeing that hey, current is greater than a dot length, then I'm out of the array. There is no tree null, and if it is a null, it's a valid tree, so return true. Or else if I'm done with the array a length, then it means that I am on the end and there's nothing left, so that is why return true. Let's compile this code and check for sample test cases. Expecting semicolons. Yes, semicolon is missing. Let's take it now. Okay, cannot find symbol. What is wrong? Right and left. Okay, I have not created right and left, so let me do it right away or left away. So I have current multiplied by 2 plus 1 for left, and similar thing for right as well, whereas right is current multiplied by 2 plus 2, and this is it. Let me try to compile this, and yes, it compiles well with sample test case. Let me try to submit, and yeah, it is submitted for rest of all the test cases. And let's understand, this wanted us to solve in time complexity of O of n without using any auxiliary space. The internal stack space is only we have used, so yeah, no auxiliary space, and yeah, time complexity is O of n. Was asked in Cisco, and it followed the topic of binary search tree, data structures, and array. Although the problem says heap, but again it's a binary search tree. But if you wanted to actually solve problems related to binary search tree or whatever, you have to understand whether the tree is binary search tree or not. Click the video on your right, and I will see you in the next one.